So, good evening, my dear students. So, in today's class, let us discuss about the D and F block elements, level 3 type of questions. So, here we have a few questions which comes under level 3. So, the first question, that is four successive members of the first row transition elements. Four successive members of the first row transition elements are listed below with their atomic numbers. Which one of them is expected to have a highest third ionization enthalpy ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. So here the highest third ionization enthalpy is what? IE3 ಅಂತ ನಾವು represent ಮಾಡ್ತೀವಿ. So ionization enthalpy ಅಂತ ಅಂದ್ರೆ ಏನು? First of all, the amount of energy is required to remove an outermost shell of an electron is called as highest third ionization enthalpy ಅಂತ ಹೇಳ್ತೀವಿ. Okay, so ಈಗ ಕೊಟ್ಟಿರುವಂತ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ವಿಚ್ ಎಲಿಮೆಂಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಹೈಯೆಸ್ಟ್ ಥರ್ಡ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ದಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದಿಸ್ ಇಫ್ ವಿ ರೈಟ್ ದ ಎಕ್ಸಾಂಪಲ್, ದ ಫಸ್ಟ್ ರೋ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ 3D ಸೀರೀಸ್ ಅಲ್ಲಿರುವಂತ ಎಲಿಮೆಂಟ್ಸ್ ಇದೆಲ್ಲಾನು. ಸೊ ಇಫ್ ವಿ ರೈಟ್ ದ ಫಾರ್ ವನೇಡಿಯಂ 23 ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ದ ಕಾನ್ಫಿಗರೇಷನ್ 1s2 2s2 1s2 2s2 2p6 3s2 3p6 3d3 4s2 will be the configuration. See, ಅದೇ ರೀತಿ ಕ್ರೋಮಿಯಂ ಏನಿದೆ, chromium 24 will be having the electronic configuration. So 1s2 2s2 2p6 3s2 3p6 3d5 4s1. Okay, then next we have manganese. Manganese Mn25 will be having the configuration 1s2 2s2 2p6 3s2 3p6 then 3d5 4s2. Okay, then next we have last one, iron. Iron will be having the atomic number 26, which gives 1s2 2s2 2p6 3s2 3p6. Then next we have what? 3d6 4s2 3d6 4s2 we have. Okay, so vanadium last configuration is 3d3 4s2. Chromium will be having 3d5 4s1. The manganese will be having 3d5 4s2 and iron will be having what? 3d6 4s2 configuration ಇದೆ. Okay, so ಈಗ ಬಿಕಾಸ್ ಆಫ್ ಡಿ ಆರ್ಬಿಟಲ್ ಪಾರ್ಷಿಯಲಿ ಫಿಲ್ಡ್ ಆಗಿದೆ, ಎಸ್ ಆರ್ಬಿಟಲ್ ಕಂಪ್ಲೀಟ್ಲಿ ಫಿಲ್ಡ್ ಆಗಿರೋದ್ರಿಂದ, ಸೊ ಅಂಡ್ ಇಟ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಕೇಪಬಿಲಿಟಿ ಟು 3d5 4s2 is the last valence shell electronic configuration of the manganese. And also here, see, actually chromium also will be having 3d5, but here s orbital is occupied by the single electron, but in case of manganese s orbital will be occupied by the two electrons. So Mn plus 2 has the Mn plus 2 actually will be having, see ಈಗ ನಾವು Mn plus 2 if we write the common oxidation state ನ ತಗೊಂಡು electronic configuration ಅನ್ನ ಬರೆದಾಗ ಲಾಸ್ಟ್ valence shell will becomes 3d5 4s0 ಆಗುತ್ತೆ. So it is having only the d5 configuration. So it has d5 configuration ಆಗಿರೋದ್ರಿಂದ, so the configuration will becomes what? 1s2 2s2 2p6 3s2 3p6 and 3d5. So 4s0 will becomes, so that because of the presence of d5 configuration, manganese will be having the highest third ionization enthalpy ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. So that option 3 is the right answer. Yes, after this next question we have, many transition metals form interstitial compounds. The characteristics of these interstitial compounds are, so ಈಗ most of the transition metals interstitial compounds ನ formation ಮಾಡುತ್ತೆ. and what are the characteristics of interstitial compounds ಅಂತ ಹೇಳಿದ್ದಾರೆ. so ಈಗ ಇದ್ರಲ್ಲಿ actually firstly let us know what is the meaning of interstitial compounds. So actually interstitial compounds are formed when the metals which are having Okay, octahedral and tetrahedral geometry. Octahedral and tetrahedral geometry ಇರುವಂತ ಮೆಟಲ್ಸು, ಆಕ್ಟಾಹೆಡ್ರಲ್ ಅಂಡ್ ಟೆಟ್ರಾಹೆಡ್ರಲ್ ಜೊಮೆಟ್ರಿ ಇರುವಂತ ಮೆಟಲ್ಸ್ ಕಂಬೈನ್ ಆಗುವಾಗ, ಸೊ ದರ್ ವಿಲ್ ಬಿ ಎ ಫಾರ್ಮೇಶನ್ ಆಫ್ ಸಮ್ ವಾಯ್ಡ್ಸ್ ಆರ್ ಎಂಟಿ ಸ್ಪೇಸ್. ವಾಯ್ಡ್ಸ್ ಅಥವಾ ಎಂಟಿ ಸ್ಪೇಸ್ ಕ್ರಿಯೇಟ್ ಆಗುತ್ತೆ. ವಾಯ್ಡ್ಸ್ ಆರ್ ಎಂಟಿ ಸ್ಪೇಸ್ ವಿಲ್ ಬಿ ಕ್ರಿಯೇಟಿಂಗ್ in octahedral and tetrahedral geometry with the metals. Okay, so combine ಆಗುವಾಗ both the metals, there will be a formation of empty space or voids in between that crystal lattice, so that ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, the non metals such as ಕಾರ್ಬನ್ ಇರ್ಬೋದು, ನೈಟ್ರೋಜನ್ ಇರ್ಬೋದು, ಅಥವಾ ಹೈಡ್ರೋಜನ್ ಇರ್ಬೋದು, ಆ ಎಂಟಿ ಸ್ಪೇಸ್ ಅಥವಾ ವಾಯ್ಡ್ಸ್ ಅನ್ನ ಹೋಗ್ಬಿಟ್ಟು ಆಕ್ಯುಪೈ ಮಾಡಿಕೊಂಡು ದೇ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಫಾರ್ಮ್ ದ ಬಾಂಡ್, ಮೆಟಾಲಿಕ್ ಬಾಂಡ್ ವಿತ್ ದ ಮೆಟಲ್ಸ್ ಜೊತೆ ಬಾಂಡ್ ಫಾರ್ಮೇಶನ್ ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಕಾಂಪೌಂಡ್ಸ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಕಾಂಪೌಂಡ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಹಾಗಿದ್ರೆ what are the characteristics of these interstitial compounds anta andre, so the first one we have, they have low melting points anta ide, they are very hard, they retain metallic conductivity, they are chemically more reactive than the pure metals anta ಹೇಳ್ತಿದ್ದಾರೆ. So apart except option 1, that is they have low melting point. So interstitial compounds melting point ಕಡಿಮೆ ಆಗುತ್ತೆ when the non metals combines with the metals, or non metals occupies the voids or empty space in the crystal lattice of the metal. Their very hard property is wrong and they retain metallic sorry, one second. So option 1 ಏನಿದೆ that is wrong. They have low melting points ಅನ್ನೋದು ರಾಂಗ್ ಆಪ್ಷನ್. ಯಾಕೆ ಅಂತ ಅಂದ್ರೆ ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್ಸ್ ಯೂಶುವಲಿ ದೇ ಆರ್ ಹ್ಯಾವಿಂಗ್ ದ ಹೈ ಮೆಲ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ಸ್ ಆಗಿರೋದ್ರಿಂದ, ಸೊ ದಿಸ್ ಇಸ್ ರಾಂಗ್ ಆಪ್ಷನ್. ದೇ ಆರ್ ವೆರಿ ಹಾರ್ಡ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಎಸ್, ಆಫ್ ಕೋರ್ಸ್ ದ ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್ಸ್ ಆರ್ ವೆರಿ ಹಾರ್ಡ್ ಇನ್ ನೇಚರ್, even though if the non-metals are occupied the empty space in the crystal lattice, so they are hard in nature, we can say. Then next option, they retain metallic conductivity anta ಹೇಳ್ತಿದ್ದಾರೆ. So yes, of course, even though the non-metals such as carbon, nitrogen and hydrogen is occupied by the voids or empty space in the crystal lattice, so that structure or the compound is not going to lose its metallic conductivity property, so that property is going to retain. So that option 3 is right answer. Then option 4 is they are chemically more reactive than the pure metals anta ಹೇಳ್ತಿದ್ದಾರೆ. So ಯಾವಾಗ ನಾನ್ ಮೆಟಲ್ಸು ಮೆಟಲ್ಸ್ ಜೊತೆ ಎಂಟಿ ವಾಯ್ಡ್ಸ್ ಅಲ್ಲಿ ಹೋಗಿ ಆಕ್ಯುಪೈ ಆಗುತ್ತೆ, ಆಗ ದಟ್ ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಕಾಂಪೌಂಡ್ಸ್ ವಿಲ್ ಬಿ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್ ದ್ಯಾನ್ ದಟ್ ಆಫ್ ದ ಪ್ಯೂರ್ ಮೆಟಲ್ಸ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ನೋ, ಪ್ಯೂರ್ ಮೆಟಲ್ಸ್ ಸ್ಟ್ರಾಂಗ್ ಇರುತ್ತೆ ದ್ಯಾನ್ ದಟ್ ಆಫ್ ದ ಇಂಟರ್ಸ್ಟಿಷಿಯಲ್ ಕಾಂಪೌಂಡ್. ಸೊ ದಟ್ ಆಪ್ಷನ್ 2 ಅಂಡ್ ಆಪ್ಷನ್ 3 ವಿ ಕ್ಯಾನ್ ಸೇ ದಟ್ ಇಟ್ ದ ರೈಟ್ ಆನ್ಸರ್. ಸೊ ಆಪ್ಷನ್ 1 ಏನಿದೆ 2 and 3 ಓನ್ಲಿ ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಆಪ್ಷನ್ 2 and 3 only the correct answers. Next, third question we have, which of the following oxides are acidic in nature? So ಕೊಟ್ಟಿರೋಂಥ ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಯಾವುದು ಮೋರ್ ಅಸಿಡಿಕ್ ಇನ್ ನೇಚರ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಇದರಲ್ಲಿ ಯಾವ ಆಕ್ಸೈಡ್ಸು ಮ್ಯಾಕ್ಸಿಮಮ್ ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ನ ಹೊಂದಿರುತ್ತೆ? ಸೊ ದ ಫಸ್ಟ್ ಆಪ್ಷನ್ ವಿ ಹ್ಯಾವ್ ವೆನೇಡಿಯಂ ಪೆಂಟಾಕ್ಸೈಡ್, ಸೆಕೆಂಡ್ ಒನ್ ಮ್ಯಾಂಗನೀಸ್ ಆಕ್ಸೈಡ್, ಥರ್ಡ್ ಒನ್ ಕ್ರೋಮಿಯಂ ಟ್ರೈಆಕ್ಸೈಡ್, ಫೋರ್ತ್ ಒನ್ ಮ್ಯಾಂಗನೀಸ್ ಡೈಆಕ್ಸೈಡ್ ಇದೆ. Among these 4 options, which one is acidic in nature anta andre, oxides with the highest oxidation state, oxides with highest oxidation state. Okay, so oxides with highest oxidation state are in acidic nature, acidic in nature anta ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, so ಈಗ let us calculate the oxidation state of one by one. The first one we have vanadium pentoxide, that is V2O5. 2 into vanadium plus 5 into oxygen is equals to 0. Then 2 into V plus 5 into minus 2 is equals to 0. Then 2V minus 10 is equals to 0. 2V is equals to plus 10. V is equals to plus 10 divided by 2. 2 5s are 10. V is equals to plus 5. We'll be getting plus 5 is the oxidation state of vanadium in vanadium pentoxide. And second one we have manganese oxide MnO 1 into Mn plus 1 into minus 2 is equals to 0. Then Mn minus 2 equals 0. Mn equals plus 2. Okay, then third option we have Cr2O3. So 2 into Cr plus 3 into minus 2 is equals to 0. 2 into Cr minus 6 equals 0. 2 Cr equals minus plus 6. Cr equals plus 6 by 2 is equals to plus 3. So chromium to plus 3 ಆಗುತ್ತೆ. Then fourth option we have MnO2. So 1 into Mn plus 2 into minus 2 equals 0. Mn minus 4 is equals to 0. Mn is equals to plus 4. Okay, so illi namge manganese to plus 1 oxidation state barutte. So if we compare all the oxidation states, we'll be getting the maximum oxidation state when V2O5. So iga according to this condition, oxides with highest oxidation states are in acidic in nature anta heltidare. So that we can choose option 1 is the right answer. Okay, next we'll move on to the next question. The magnetic moment of an ion is close to 36 into 10 power minus 24 joule per Tesla. The number of unpaired electrons of the ion are option 1 4, 2 2, 3 1 and 4 3. So here magnetic moment is equals to mu is equals to 36 into 10 power minus 24 joule per Tesla is given. Okay, then we know that one Bohr magneton is equals to 9.273. Correct? 9.273 into 10 power minus 24 joule per Tesla. Correct? So, ಈಗ number of unpaired electrons is equals to mu divided by mu by 1 Bohr magneton. That is equals to 36 into 10 power minus 24 joule per Tesla divided by 9.273 into 10 power minus 24 joule per Tesla. So, ಇಲ್ಲಿ 10 power minus 24 joule per Tesla cancel. 36 by 9.273 is nothing but 3.8 something answer will be getting. So, andre almost ನಮಗೆ number of unpaired electrons will be equals to 3 ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. So, n is equals to 3. So, we have option 4 is the right answer. Okay, next question. The Nessler's reagent, the active ion is. So, actually Nessler's reagent is, it is the aqueous solution of potassium iodide plus mercury chloride HgCl2 plus will be having Hg2Cl2. Okay, Hg2Cl2 plus potassium iodide we have Ki mercuric chloride. Okay, then KOH. KOH, or we can also K2HgI4, chemical formula for, so all together combined to give, it is going to give the product K2HgI4. So idu namge ionization adaga it is going to give 2K plus Hg4I2 minus. Okay, so Hgi4 2 minus. Hgi4 2 minus will be getting the product. Okay, so that we can choose the active ion ಯಾವುದು ಅಂತ ಅಂದರೆ, so Hg(I4) 2- will be the active ion. Hg(I4) 2- will be what? Active ion, we can say. Next question we have sodium chromate on treatment with lead acetate. Sodium chromate on treatment with what? Lead acetate gives a precipitate. This dried precipitate is used as a pigment for road signs and markings. The solid is known as. So sodium chromate na it is going to treat with the lead acetate ಜೊತೆ treat ಮಾಡಿದ್ರೆ, ಓಕೆ, ಲೆಡ್ ಅಸಿಟೇಟ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ಪ್ರೆಸಿಪಿಟೇಟ್ ಫಾರ್ಮೇಶನ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ದಿಸ್ ಡ್ರೈಡ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ನ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂತ ಅಂದ್ರೆ ಆಸ್ ಎ ಪಿಗ್ಮೆಂಟ್ ಆಫ್ ಫಾರ್ ರೋಡ್ ಸೈನ್ಸ್. ಸೊ ಈಗ ನಾವು ರೋಡ್ಸ್ ಅಲ್ಲಿ ಯೆಲ್ಲೋ ಕಲರ್ ಲೈಟ್ಸ್ ನ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು. ಸೊ ದಟ್ ಈಸ್ ಮೇಡ್ ಬೈ ವಾಟ್? ದಟ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ಅಂಡ್ ಆಲ್ಸೋ ದ ಮಾರ್ಕಿಂಗ್ ಪರ್ಪಸ್ಗೋಸ್ಕರ ಯೂಸ್ ಮಾಡಿರ್ತಾರೆ. ದ ಸಾಲಿಡ್ ಈಸ್ ನೌನ್ ಆಸ್ ಅಂತ ದರ್ ಆಸ್ಕಿಂಗ್ ದ ಕ್ವಶನ್. ಆಪ್ಷನ್ಸ್ ಆರ್ ವೈಟ್ ಲೆಡ್, ಕ್ರೋಮ್ ಗ್ರೀನ್, chrome yellow, red lead ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So now if I write the reaction, when Na2CrO4 sodium chromate is treated with the lead acetate CH3COO twice, will be getting the product 2 moles of CH3COO Na plus lead chromate will be getting. So this is the precipitate which is yellow in color. Okay, also call it as yellow chrome or chrome yellow. So option 3 is the right answer. Next question, which of the following sulfides is yellow in color? Zinc sulfide, nickel sulfide, cadmium sulfide and magnesium sulfide is given. So idralli usually all the sulfides are yellow in color. Sulfides are yellow in color. So all the sulfides are yellow in color. So then zinc sulfide bandaga. So zinc sulfide is first white in color when it is in pure form. White color in pure form. White color in pure form and black color in impure form. Black color in impure form. Black color in impure form. Okay. So then next we have zinc sulfide done. Then next we'll be getting nickel sulfide and lead sulfide. So these two are black in color. Okay na. So iga yellow color irodu yava sulfides anta heltidare. So we can say that option 3 cadmium sulfide ಏನಿದೆ. ಸೊ magnesium sulfide also black in color ಇರುತ್ತೆ. Cadmium sulfide will be, we can see in terms of yellow in color. Cadmium sulfide is yellow in color, we can say. Okay, next we have 8th one, which of the following are correct about zinc, cadmium and mercury? So related to zinc, cadmium and mercury, few statements are given. So the first statement is the exhibit high enthalpy of atomization as the d subshell is full ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಅಂದ್ರೆ d completely filled d orbital ಇದ್ದಾಗ exhibit high enthalpy of atomization ಅನ್ನ exhibit ಮಾಡುತ್ತೆ. Second statement is zinc, cadmium do not show variable oxidation states. Mercury can show +1 and +2 states ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Option 3 is compounds of zinc, cadmium, mercury are paramagnetic in nature. Option 4 they are soft metals ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Okay. So ಈಗ among these 4 statements, which one is correct regarding zinc, cadmium, mercury they are telling. So the answer is they exhibit high enthalpy of atomization as the d subshell is full ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. This is wrong option. But zinc, cadmium do not show variable oxidation states. Mercury can show +1 and +2 ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Yes, obviously mercury is present in the form of +1 and Hg+2. But zinc will be we can do not show. Zinc is present in the form of Zn+2 and cadmium +2. Then compounds of zinc, cadmium, mercury are paramagnetic anta ಹೇಳ್ತಿದ್ದಾರೆ. This is wrong option. See, if we write the electronic configuration, we can see there is no unpaired electrons are present. Next, they are soft metal. Yes, obviously, zinc, cadmium and mercury are the soft metal. So that we can tell option 2 and option 4 are the correct answer. So, option 3 alli we can see second ಮತ್ತೆ fourth option correct ಇರೋದ್ರಿಂದ third option is the right answer. Next we have, which of the following factors may be regarded as the main cause for lanthanide contraction ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸಿ ಇದರಲ್ಲಿ ವಿಚ್ ಆಫ್ ದ ಲ್ಯಾಂಥನೈಡ್ ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಗೋದಕ್ಕೆ ಯಾವ ಫ್ಯಾಕ್ಟರು ಮೇನ್ ಆಗಿ ಕಾಸ್ ಆಗುತ್ತೆ ಅಂತ. ಸಿ ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಒನ್ ಆಫ್ 4f ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೈ ಅನದರ್ ಇನ್ ದ ಸಬ್ಶೆಲ್. ಸೊ 4f ಆರ್ಬಿಟಲ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 1 ಎಲೆಕ್ಟ್ರಾನ್ ಪ್ರೆಸೆಂಟ್ ಇರೋದ್ರಿಂದ ಸೊ ಅಲ್ಲೇನಾಗುತ್ತೆ, ಪುವರ್ ಶೀಲ್ಡಿಂಗ್ ಎಫೆಕ್ಟ್ ವಿಲ್ ಕಾಸ್. Then second option, effective shielding of one of 4f electrons by another in the subshell. Third option is poor shielding of 5d electrons by 4f electrons. Fourth one is poor shielding of 4f electrons by 5d electrons anta kottidare. So in this we can choose the answer poor shielding of one of 4f electrons by another in the subshell we can choose. Okay, so option 1 is the right answer. ಆಪ್ಷನ್ 1 ಏನಿದೆ ಅದು ರೈಟ್ ಆನ್ಸರ್ ಅಂತ ನಾವು ಚೂಸ್ ಮಾಡ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ವಿ ಹ್ಯಾವ್ calomel on reaction with NH4OH. Okay, so HgCl2 is the calomel electrode alli. So it is calomel electrode will be the secondary reference electrode. As of we are using She as a primary reference electrode. Okay, so because we know the electrode potential of She, so that is 0 volt. So She do electrode potential value 0 volt irutte. So by knowing the electrode potential of one electrode, we are going to find out the electrode potential of the another electrode. So in that case, we are going to use the calomel electrode value. Namge gottagbeku andre electrode potential value. By taking the reference as a She, we can find it out. So that calomel electrode will be filled with the mercuric chloride is treated with the NH4OH. So we'll be getting the product HgNH2Cl we are getting, and with the liberation of some amount of HCl. Okay, so that HgNH2Cl product we call it as that product is there in option 1, so that option 1 is the right answer. Next question, percentage of copper is minimum in. So these are the options that whatever they have given, all those we call it as alloys anta ಹೇಳ್ತೀವಿ. So brass alloy ಏನಿದೆ, that is made by copper and zinc. So brass alloy is made by what? Copper and zinc. Bronze alloy is made by copper, zinc and tin. Copper ಮತ್ತೆ zinc and tin ಇಂದ ಮಿಕ್ಸ್ ಆಗಿರುತ್ತೆ. All these metals mixed together in a composition, they are going to give what? Bronze alloy. Then duralumin anta ide, so that is made by aluminum with copper irutte plus magnesium irutte plus manganese irutte. Okay, then if we come to the gunmetal, copper is 88%, then tin is 10% irutte, tin is 10%, then zinc 2% present irutte. Zinc will be present in 2%. So this is the composition for gunmetal. Okay, so ಈಗ ಇದರಲ್ಲಿ ಕಾಪರ್ ಮಿನಿಮಮ್ ಪರ್ಸೆಂಟ್ ಯಾವ್ದ್ರಲ್ಲಿ ಇರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ ಡ್ಯುರಾಲ್ಯುಮಿನ್ ಏನಿದೆ, so in that copper will be present in a minimum quantity, so that we can choose option 3 is the right answer. Next question we have, the number of moles of KMnO4 that will be needed to react completely with 1 mole of ferrous oxalate. 1 mole of ferrous oxalate FeC2O4 in acidic solution. Acid medium alli KMnO4, how many number of moles of KMnO4 will be required to oxidize and also how many number of moles of number of moles will be required for to react with the ferrous oxalate in acidic medium anta keltidare. So actually regarding KMnO4 we know that KMnO4 is strong oxidizing agent. Strong oxidizing agent. Okay, so KMnO4 is strong oxidizing agent. It oxidizes both iron. So Fe2 ನು ಆಕ್ಸಿಡೈಸ್ ಮಾಡುತ್ತೆ and oxalate ion C2O4 2 minus ನು Fe2 and C2O4 2 minus oxalate ions ಅನ್ನು ಸಹ ಆಕ್ಸಿಡೈಸ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಸೊ ದಟ್ ಈಗ ನಾವು oxalate oxidation in presence of KMnO4 ಯಾವ ತರ ಆಗುತ್ತೆ ವಿಲ್ ಸಿ. ಓಕೆ, ಸೊ 2 moles of MnO4 minus will be undergoes the reaction with acidic medium and also with the oxalate ion 5 moles of C2O4 minus 2 minus, it is going to give 2 Mn plus 2 plus 8 moles of water plus 10 moles of carbon dioxide is going to form. Okay, then next we have ಮತ್ತೆ iron na how the KMnO4 is going to oxidize andre iron 2 oxidation reaction will be like MnO4 minus plus 8H plus 5Fe plus 2. 5Fe plus 2 gives rise to Mn2 plus 4 moles of water plus 5 moles of Fe3 plus is going to reduce. So ಇಲ್ಲಿ ನಮಗೆ 5 moles of oxalate, this is the complete reactions complete oxidation reaction. So ಈ 5 moles of oxalate ions involve ಆಗಿದೆ and here 2 moles of KMnO4 and here 1 mole of KMnO4, so that we can take 3/5 moles of KMnO4 is required to oxidize both oxalate ions as well as the iron 2. So in that 3/5 2 moles of 2 moles for oxalate, 2 moles for oxalate and 1 mole for iron. 2 moles for oxalate and 1 mole for iron will be required, so that we can choose the answer option 3. Option 3 is the right answer. Next question we have 13th one, potassium manganate. So potassium manganate will be having the formula K2MnO4. Okay, can be converted into potassium permanganate, that is KMnO4, by oxidation method in the presence of what they are asking. Actually the potassium manganate will be oxidized to the potassium permanganate by electrolytic oxidation. Okay, so electrolytic oxidation by chlorine, in the presence of chlorine, and also disproportionation reaction. Okay, so that we can choose all the 3 points are here, so that we can choose with chlorine, with ozone and with electrolytically the potassium manganate will be converted into the potassium permanganate by oxidation method. So the correct statement is all the 3 statements are correct, so that we can choose option 1 is given 1 only, option 2 is given 2 only, option 3 is given 3 only, option 4 is first, second and third. So we can choose option 4 is the right answer. Next question we have 4 successive members of the first row transition elements are listed below with atomic numbers. Which one of them is expected to have the highest electrode potential value of M plus and M plus 2 value? Okay, so that is, so if we come to the chromium, so electrode potential, see for this we should know the standard reduction potential table, then only we can able to answer for this question. So if we write the electrode potential value for chromium plus 3 to chromium plus 2 will be having minus 0.41 volt. Then next one we have electrode potential value for Fe plus 3 to Fe plus 2. So that is equals to plus 0.77 volt. Then electrode potential for Mn plus 3 to Mn plus 2 will be having plus 1.57 volt. Okay, then next will be having E naught of cobalt plus 3 to cobalt plus 2 will be having plus 1.97 volt. Okay, so ಈಗ if we compare all the values, reduction potential value or electrode potential values, no, so cobalt will be having the highest electrode potential value, so that we can choose option 4 will be the correct answer. Okay, na, so that we can choose option 4 is the right answer. Next, we'll move on to the next question. When H2S is passed through HgCl2, we get, so H2S na, when we pass into the mercuric chloride solution, HgCl2 ಗೆ pass ಮಾಡಿದ್ರೆ will be getting, so where H2S is a gas and mercury chloride it is a aqueous medium solution, it is going to give HgS, mercuric sulfide plus 2 moles of HCl is going to form. So HgS is the product, so that we can choose option 1 is the right answer. So after this we have next question. The oxyanion which contains all equivalent metal oxygen bond is. So oxyanion which contains all equivalent metal oxygen bond is means, so they have given the options CrO4 2 minus, CrO4 2 minus will be the first one, and the second one we have MnO4 minus, and third one we have Cr2O7 2 minus. Okay, so ಈಗ metal and oxygen bond ಯಾವುದರಲ್ಲಿ equivalent ಆಗಿರುತ್ತೆ ಅಂದರೆ, so if we write the structure of CrO4 2 minus, so Cr, it is having the tetrahedral geometry O4 2 minus. Okay, and another one we have MnO4 minus. Then third option we have Cr2. So and here there is a presence of one bridged oxygen. So we'll be having what? 2 minus. So among these structures, the metal and the oxygen bond ಯಾವುದರಲ್ಲಿ equivalent ಆಗಿರುತ್ತೆ ಅಂದರೆ, so we can choose option 1 ನಲ್ಲಿ strongly all the metal is linked with the oxygen, we can say, so that option 1 only is not this one, sorry 1 second. Yes, in option 1 and option 2 equivalent ಆಗಿ ಪ್ರೆಸೆಂಟ್ ಇರುತ್ತೆ. ಇನ್ ಕೇಸ್ ಆಫ್ ಆಪ್ಷನ್ 3 ಅಲ್ಲಿ ಬ್ರಿಡ್ಜ್ಡ್ ಆಕ್ಸಿಜನ್ ಆಟಮ್ ಪ್ರೆಸೆಂಟ್ ಇರೋದ್ರಿಂದ, ಸೊ ಆಪ್ಷನ್ 1 and 2 ಆರ್ ದ ರೈಟ್ ಆನ್ಸರ್ಸ್. ಸೊ ಆಪ್ಷನ್ 3 ಅಲ್ಲಿ 1 and 2 ಇರೋದ್ರಿಂದ ವಿ ಕ್ಯಾನ್ ಚೂಸ್ ವಾಟ್ ಆಪ್ಷನ್ 3 ಇಸ್ ದ ರೈಟ್ ಆನ್ಸರ್. Then next we will be having the question, because what's the reason means, because they have same bond length. They have same bond length. Okay, so then next we'll move on to the next question. The non-transition metal present in German silver is non-transition metal. So transition metal ಅಲ್ಲದೆ ಇರುವಂತ ಮೆಟಲ್ which one is present in German silver ಅಂತ ಅಂದ್ರೆ, so that is zinc. Okay, so German silver ಅಲ್ಲಿ present ಇರುವಂತ ನಾನ್ ಟ್ರಾನ್ಸಿಷನ್ ಮೆಟಲ್ ಯಾವುದು ಅಂತ ಅಂದ್ರೆ we can say it is zinc. Next we have, in context with the transition elements, which of the following statements is incorrect. ಸೊ ಆಸ್ ಪರ್ ದ ಟ್ರಾನ್ಸಿಷನ್ ಎಲಿಮೆಂಟ್ಸ್ ಪ್ರಕಾರ ಕೊಟ್ಟಿರುವಂಥ 4 ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ವಿಚ್ ಒನ್ ಈಸ್ ಇನ್ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಹಿಯರ್ ವಿ ಕ್ಯಾನ್ choose the answer, that is yes. So here we'll be having the statements in addition to the normal oxidation states. Transition elements alli in normal oxidation states irutte. The zero oxidation state is also shown by these elements in complexes. The same transition elements complexes alli present idre they can able to show oxidation state will be zero nu torso possibilities irutte anta heltidare. So yes, of course this is right option. Okay. And second option we have, in the highest oxidation states, the transition metal show acidic character and form cationic complexes. See, this question is, this is not acidic, this is basic. Okay. So in this statement, in the highest oxidation states, the transition metal show basic character and form cationic complexes anta heltidare. So this is wrong statement. Yake anta andre, so the compounds which are having the highest oxidation states, they are acidic in nature. Okay. And also they can able to form cationic complexes. So that illi basic character anta kotirodrinda this is incorrect statement. And third option we have, that is statement, in the highest oxidation states of the first 5 transition elements. So scandium to manganese, all the 4s and 3d electrons are used for bonding anta heltidare. So this is also correct statement. Then fourth option we have statement, once 5d configuration is exceeded, 5d configuration complete ಆದ್ಮೇಲೆ the tendency to involve all the 3d electrons in the bonding decreases. So this is also right statement. So illi namge option 2 alli they have given the wrong statement, so that we can choose option 2 is the right answer, but it is the wrong statement. Okay, so next we'll move on to the next question. Iron exhibits +2 and +3 oxidation states. Which of the following statements about iron is incorrect? So iron +2 ಮತ್ತೆ +3 oxidation state ನ exhibit ಮಾಡುತ್ತೆ. But ಇಲ್ಲಿ which of the following statements about iron is incorrect ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. The option 1 is ferrous compounds are relatively more ionic than corresponding ferric compounds. So ferrous ಅಂತ ಅಂದ್ರೆ Fe+3 ಇರುತ್ತೆ. So ferric ಅಂದ್ರೆ Fe+2 ಇರುತ್ತೆ. Okay. So then ferrous compounds are less volatile than the corresponding ferric compounds. Then option 3 is ferrous compounds are more easily hydrolyzed than the corresponding ferric compounds anta ide. And option 4, ferrous oxide is more basic in nature than the ferric oxide anta ಹೇಳ್ತಿದ್ದಾರೆ. Okay. So here the ferrous compounds are less volatile than the corresponding ferric compounds ಏನಿದೆ, that is the incorrect statement ಅಂತ ಹೇಳ್ತೀವಿ. And all remaining other statements are related to the iron only. So the incorrect statement is ferrous compounds are less volatile than the corresponding ferric sorry, not this one. So option 3, that is ferrous compounds are more easily hydrolyzed than the corresponding ferric compounds anta ಏನಿದೆ, that is the incorrect statement. Apart from the third option, remaining all the options, that is first, second and fourth options are correct related to the iron which is having the oxidation states +2 and +3. So that we can choose option 3 is the right answer. The next question we have, transition metal present in the alloy that is gunmetal is ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. So for this we should know the composition of gunmetal. So in gunmetal there is a presence of copper will be 88%. Okay, and tin is present 10%, and another one that is zinc. Zinc is present in 2%. So the maximum percentage of transition metal present in the alloy that is gunmetal is copper 88%, so that we can choose option 4 is the right answer. Okay, next question we have, which one of the following does not contain silver ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. So they have given the brass, German silver, bronze and bell metal. So brass is having copper and zinc. Okay, then bronze is having copper, zinc and tin metal. Okay, tin. Then German silver, it is contain a non-transition metal. German silver composition is the alloy German silver composition is so which contains copper alloy plus nickel plus zinc, which is here zinc is present as a non-transition element. Okay, so zinc that is 60% copper irutte, and nickel is 20% and zinc is 20%. Okay, so this is the composition of what? German silver. Then composition of bell metal is, so which is having 78% of copper. Bell metal is having the composition 78% of copper, then 22% of tin. 22% of tin. Okay, so here which one of the following does not contain zinc? So zinc ಇಲ್ಲದೆ ಇರುವಂತ alloy ಯಾವುದು ಅಂತ ಅಂದ್ರೆ bell metal. So in bell metal there is no zinc transition metal, so that we can choose option 4 is the right answer. Next question we have, which of the following is a constituent of lithophone? Lithophone meaning, so it is an instrument. So lithophone is what? It is an instrument made up of stone. Made up of stone whose sound is produced by striking. Produced by striking. So lithophone is an instrument which is made up of what? Stone whose sound is produced by striking. So that for this the correct answer is zinc. Which of the following is a constituent of lithophone anta andre? So the zinc sulfide. Zinc sulfide is the constituent for lithophone. So with this we'll stop the level 3 type of questions. In next class we'll continue with the previous year solved questions.